Hey everyone, Chloe Condon again, and I am here with Jim Bennett today, and we're talking about gathering data from all around the world. Welcome, Jim. So I'm super excited to talk to you about this because I know you are our IoT go-to person on the team. So I guess my first question here is tell us a little bit about IoT. Isn't it just kind of like, I think when we think of it initially, we're thinking of circuit boards and blinky lights, but what can we do with data in IoT?
Yeah, no, that's actually a really good question because a lot of people, when they think of IoT, like you, they think it's a circuit board. I've got some lights. Yeah, like their kind of 101 project is, can I get an LED to light up? Which is very cool when it happens. But people think of things like Raspberry Pis or Arduinos or kind of custom circuit boards gathering data, and that's kind of the limit of what a lot of people imagine when they think of IoT. But actually, IoT is a lot more. It's really kind of three things. You've got things, insights, and actions. So the things are these IoT boards. That would be your Raspberry Pi, your custom silicon, your thing that's gathering data. But then you want to create some insights. You want to do something with that data to actually get insights into what the data means and what you should do with the outputs of that data. And that then turns into actions, which is where things happen based off those insights. So kind of the canonical demo would be the kind of the smart thermostats or the Nest thermostats, those kind of things. It sits on your wall. It's a thing, gathers temperature data. But that data then is analyzed in the cloud and it's augmented with other data, such as your calendar. And then it can use that to make decisions. So, for example, it can look at the temperature of your house, see that it's too cold, look at your calendar, see that you're on holiday, and do nothing. Or it could look at the temperature, see that the house is too cold, see that it's only going to get colder from a weather report, see that you're going to be at home all day, and then the action there will be to turn the heating on. So it turns that data, augments the data to get insights, and then an action comes out at the end and something then happens, whether that's alert a person, control a machine, turn on a light, what have you.
Yeah, and I think it's something, maybe a concept that may be difficult for people who are newer to IoT is we have these devices, maybe it's a little button or it's our thermostat on the wall, but where do we store that data? It's certainly not inside of the device, so what magical thing, maybe it rhymes with loud, I don't know. Where are we storing this data, Jim?
Yeah, have you heard this thing called the cloud? I'm not sure if you've heard of it. But
Oh,
Microsoft
yes,
has.
yes, yes. Azure, perhaps.
That's the one. Yeah. So we have these devices, they gather data, and we have a whole load of SDKs that allow you to take the data off the device and send it up to the cloud. So I'm going to do a cool demo, if we can just flip to my demo. What we have going on here is my assembly line. I am manufacturing Lego Stormtrooper minifigs. Now, obviously, this is just a toy mock-up, but this is similar to the kind of thing you'd get in a real factory where you're gathering data and sending that data to the cloud. In this particular one, I've got a control circuit here. I press a button. It talks to my thing, my Raspberry Pi over here. That then talks to another thing, which is an ESPI camera. It takes a photograph of the device in the assembly line, the Stormtrooper. It runs AI across that to make sure that my Stormtrooper has been assembled correctly, sends the results to the cloud, and then my action, a light comes on. It's green, my Stormtrooper's fine. But if my Stormtrooper was, say, broken, let's break them down there, do the same thing, I would get red light, I'll get a failure. So my data is being gathered by my device. There's insights happen in the cloud, and then we're seeing the actions in the form of, in this case, the green light, and then now the red light. Now, all this happens inside a service called Azure IoT Hub. So IoT Hub is fundamentally a big pipeline. It's a big pipe that connects your IoT devices to the cloud. So it doesn't really do much with the data. It just literally takes the data and sends it to the cloud. It can also control your device. So my Raspberry Pi uses IoT Hub to send a message to the ESPI to take the picture. But once you've got data into IoT Hub, you kind of need to do more with it off the other end. So my data comes in, hits IoT Hub. Where next? The next stage to actually get that data into a database would be to do some kind of real-time streaming analytics on my data. And there's a service in the cloud called Stream Analytics. And this can take the raw data that comes into your IoT Hub. You run a query over that data. It's kind of a SQL-like query. And then the results of that query go somewhere else. In this particular example, my IoT Hub data comes in. My query is literally, give me the device ID, the result, is my Stormtrooper built successfully or not, and the time, and it selects it into Cosmos DB. And Cosmos DB is a globally distributed uber powerful database, stores data in various different document formats, and I like it because I find it really quick to get started with. And so I'm querying my data. Every time a message comes in from IoT Hub, it gets run through this query pretty much in real time and gets selected out into Cosmos DB. And then I can just go into my Cosmos DB database, and here are my results. And in fact, if I just refresh it, we'll should see some more results appearing on the end of where I've just run those last two jobs. And the results that sit in there are these JSON documents that say whether or not it's passed or failed. So again, a few more results on the end where I've been playing with it. And so it shows the pass or fail. So I've managed to get my data in real time, and I've streamed it into a database so I can then do insights on this, do more analytics on it, and then do something with the output of that.
First of all, love that you used a very important real world scenario, which is making sure that your Legos are put together correctly. But I imagine we're getting a whole bunch of data, like, is it a stormtrooper? Is it Darth Vader? How many different pieces of data are we getting? Can you get pretty specific with these analytics?
Oh, totally. It's up to you how much data you want to gather. There is kind of almost like there's no limit as to what you want. I mean, in this particular case, I've trained an AI model just to distinguish between my stormtrooper in one piece or two, but I could then do something to determine whether it's a stormtrooper or Darth Vader. Did it go onto the wrong production line? I can just gather so much data. And once I've got the data, there's a lot of things I can do with it. It's not just about querying this and putting it in a database. I can build some really powerful analytics on this data using Stream Analytics. So I've got another one here.
Some visualizations. I do love a good data visualization.
We do love data visualization, yes. So I've got some cool data visualizations going on here, I would say. This is one, I don't have the hardware for this at the moment. I had to dismantle it to get my assembly line working, but I was monitoring sound data. So this is using a thing called IoT Central, which is a software as a service platform that sits on top of IoT Hub, and it allows you to visualize your data with basically a drag and drop type interface. So you tell it the type of data that's going to come off your device. You can say whether it's going to be the type of minifig or sound or temperature or what have you. And you can then just drag and drop and say, I want this chart, I want this chart. And so I was gathering some sound data from my house while some workmen were working on the house next door. And I was picking up these volume levels. And IoT Central, I can literally say, plot a chart using the last 100 values, the last half hour, the last hour. But then I can take my data from IoT Central, put it back into Stream Analytics, and run more advanced analytics on it. In this particular case, because there was a lot of loud banging, I wanted to look for anomalies in sound data. I want to look for the spikes in the data, the loud noises. And this is the kind of thing you would do, say, in a factory where you have an assembly line. If one of the wheel bearings on the assembly line is failing, it's going to start making noise. So you kind of want to monitor the background noise to see, is there a problem with the piece of machinery? Is it too loud for human hearing? Things like that. So I've got this slightly more advanced query going on here. It comes from my IoT data. It goes into a Cosmos DB database, but rather than just select the data, I'm saying partition the data by the device and time. So pull out, every time a record is received, pull out the last 600 seconds, 10 minutes of data for this particular device, and then run this anomaly detection algorithm over it. This is a machine learning model that looks for spikes in data or dips, so whether it's too high or too low. In this case, I'm saying, give me the spikes, and it pulls out whether the data is a spike and sends that off to Cosmos DB. So it's not just about getting the data as is, it's about running machine learning models over that data. And then when my data is in Cosmos DB, it's in a database, it's records in a database, I can look at that in the database. But also, Cosmos DB has a great feature for visualizing data. You can run Jupyter notebooks. So Jupyter Notebook is a notebook that mixes text and code. You can run the code and you can see the output. And that can be just raw text output. It can be charts. It can be pictures. In this case, this notebook is running inside my Cosmos DB database, got full access to my data, and it's running Python code to plot a chart of my sound levels and my spikes. So this is the sound level. Kind of generally getting louder as things were happening throughout the day, and all these spikes where hammers were going off as roofs were being nailed. And then here's a plot of my anomalies. So I can visualize over the period of time that I'm running my data, where the spikes are in my data. Where is the anomaly? We're seeing here, we've got this first spike here, corresponds to an anomaly. Then here, a few more spikes. Because the anomaly detection is looking over a period of 10 minutes, it thinks that's kind of normal. But as we go along, it spots more of these spikes. And so it actually shows me the anomalies in my data. So this is a great way for like a data scientist to create insights over the data after the fact. They can look back over it, they can plot their data, they can run these kind of queries and see what's there. Also, it could be done as real-time insights. So I could take my anomalies, and if there's a big spike, immediately shut down the machine, do an alert, tell people to get out of Dodge because it's too loud, things like that.
Well, it looks like now you have this really great piece of visual data that you can give to your next door neighbor and show them just how noisy the construction work. I'm always about facts versus feelings. So this is great data, Jim.
This is data-driven neighborhood complaints all in one. Yeah.
Yes, absolutely. Well, this is so cool. And it's made me think about IoT in a different way. I think usually, like you said, we think of these blinking light LED kind of things, but even just thinking about how incorporating things like tracking sound and movement, there's so many cool ways to not only track data, but visualize the data. So thank you for sharing it with us. Where can people get started if they want to learn how to do similar things within IoT Hub?
Yeah, of course. So I've got this collection we've built inside Microsoft Learn. If you haven't come across Microsoft Learn before, it's our online self-guided hands-on learning platform. You can go in there, you can learn how to do pretty much anything with the Microsoft Cloud technologies. And most of it runs inside a sandbox. So it won't cost you anything to access any of the data. You can literally just go there, you can spin up a resource inside a sandbox for free and learn how to do stuff. And I've put together a whole load of IoT learning paths into what's called a collection. So you can take this collection and you can get yourself up to speed with IoT. Go to aka.ms/. I've completely forgotten the link. IoT learning paths. Oh, my brain. Yeah. aka.ms/IoT learning paths. And you can go straight to this link. I assume someone's going to put the link across the bottom of the screen too.
Right over here.
Right,
yeah. And I mean, what I love about Microsoft Learn is even as cloud advocates, I use Microsoft Learn all the time to learn about our own technologies, and it's such a great, wonderful free resource. So definitely check out those IoT learning paths because you can get started today for free in a sandbox. It's great.
Yeah, and as you say, even those of us who do this day in, day out, we're still learning new things all the time. When I was playing with this, and I learned about a new cool thing. Which do we have time for me to show off one more cool demo?
Do we?
One more cool demo. Okay, this is a live video analytics going on. I've got a Jetson Nano. It's a GPU made by NVIDIA running underneath my stairs, connected into my router. It's taking a video here and it's running live video analytics over this video. So in real time, it's looking for people, motorbikes, cars in the video. And then it sends it to a service called Azure Time Series Insights, where I can build a real-time dashboard of the data. I can see the people in real time. I can see the cars in real time. And this is great for that live response of what is happening with the world right now. What is the state of my factory? I actually ran this back in the days when conferences were in person. Back in January, I was running this at a conference in London, and I had this set up on a webcam, and you could actually tell when lunchtime was because I could look over the data and see the people going up between sessions, then dropping down for a session, then kind of going up and then dropping down at lunchtime. It's a great way to get real-time visualizations over my data. And this is something I just found just by playing with Microsoft Learn. It's like, oh, here's a new service I don't know about. Let's learn about this and let's come up with these cool demos. So yeah, fantastic set of resources here on using IoT. Get in there, get playing, learn the thing.
Amazing. Well, thank you, Jim, and good luck everyone with getting started with your IoT projects. We're, of course, always here to answer your questions on the interwebs on Twitter, and thanks for joining us. Thanks, Jim.
Thank you. Most fun.